Okay, welcome back to another episode of designing and building a model rocket capable of thrust vector control. In the last episode, we worked in OpenRocket, designing essentially a basic layout of a rocket so that we can bookkeep all of the internal components that we're going to have to design that will be a part of this assembly. I've gone ahead and made some minor adjustments to the sizes of the relative components from the last video, just to give myself a better understanding of how much room we're working with for each area. Specifically, I want to know how much room we had for the electronics bay and components, and also for the parachutes and stuff. As you remember, we started with the nose cone with our ballast system. We got a parachute and shock cord in this big component. The nose cone will separate from the airframe here when the ejection charges blow. We have our electronics bay here in the middle that will be responsible for collecting information such as our orientation and altitude, and controlling the thrust vector system, as well as ejecting the parachute when we reach apogee. And then at the bottom we have our fin can assembly with our removable fins that are capped with a boat tail. And then we have our motor and our thrust vector system down here. So today we're going to work on is designing the CAD for the airframe assembly. In future videos, we'll go through the other components, being the fins, the boat tail, the nose cone, and all the internal components. But for today, we're just going to do the airframe structure itself, which would be composed of the outer tube, the motor tube, and the centering rings. I was going to use a CAD software called Creo Parametric, but it is more of an educational suite. So if you are at a university as an engineering field, you can download it for free as an educational version. Otherwise, you have to pay a pretty penny to even get access to it. So instead, we're going to be using OnShape, which is owned by the same company, but it is a free software that you can use at home. It works in a web browser, so Google Chrome or Safari or Mozilla Firefox. If you want to acquire this, I'll have the link in the description to this website. But what you do is you go to pricing and scroll all the way to the very bottom, where you have a hobbyist and makers section, which is free to use for anyone. So all you have to do is create an account, and you'll then be put into this. When you open up and you go to the CAD side of their site, you'll be in this little workspace here, where this is the main workspace where you have your recent projects. You have folders that you can organize. I'm new to this. This is the 5th time I've used this software, so I don't have proper organization yet. But we're working in the thrust vector control project. As you can see, I've already done a basic assembly of the rocket that will be seen in future videos. But today we're going to start from scratch. In order to create a new CAD file, you just go to Create and Create Document. And then we're going to name this TVC 01. And when you create it, it brings you into this nice little environment. So in this environment, you have 2 tabs down here at the bottom. You have a Parts Studio, which is where you design all your parts. And then you have your Assembly 1, which you could create multiple assemblies, especially if you're going to have sub-assemblies, which we will have. Today, this sub-assembly is going to be the airframe itself, which is composed of 4 components that will be rigidly connected. So in this Parts Studio, you have your 3 datum planes, top, front, right, and you have your origin at the middle. You can maneuver around by you can spin the environment around by right-clicking and holding and spinning, or you can middle-click and drag, and you can actually pan around. If you don't want to use those tools, you have quick options over here. You can do an isometric view, a dimetric view, a trimetric view, and you have various zoom options here. With the scroll wheel, you can zoom in and out as well. You also have this nice little cube up here, which is for quick snapping to different views, which will be useful for when we sketch different components. To design components, everything begins with a sketch. So if you want to extrude a part, which is just simply taking a sketch and filling it linearly, or you want to revolve that sketch around some axes, you can do some other more advanced options, sweep and lofts, which create really complex parts. So first you start with a sketch, then you can do your desired feature to create the solid that you want to do. And then after that, you have some tools that you can modify. You have the fillet tool, which is made for rounding sharp corners. You can chamfer those corners as well. You can draft certain faces to give them some angle, add some ribs, shell out the components, and also put some holes. Here you can create patterns. So you got linear patterns, circular patterns for if you're going to have like multiple, say for instance, you want to create a single rib. Well, you can create the single rib and then you can pattern it in any direction that you want. You can mirror objects as well. And then I haven't really gotten to many of these. Last one I'll just touch on is this Boolean and Split. The way the part studio works, for at least for how I understand it, is you can design all of your parts in this one little window here. After you design a single part and you're done with it, you hide it, therefore so that you can create your next part. If you don't hide previous parts and any of the parts actually intersect physically, they will be deemed as a single part. But for instance, if you have a few parts, or say you want to design multiple parts, but you want them to be essentially the same part, so when you go to the assembly, you can assemble it as one option. You can use this Boolean option here, and then that gives you the option of merging things into a single part. So you'll see that when we get to the nose cone design, when we do the ribs, it's going to be a little necessary. And then Split essentially does the opposite. You can split things apart. The last thing I want to touch on in this toolbar at the top is this plane here. So if you wanted to create a sketch or extrude out of some other plane, not these basic three, you can create planes, offset them, arrange angles and whatnot. So to begin, we're going to start with the airframe. So we're going to start with the motor tube first because it's the simplest part. So I get all my dimensions from Apogee Components because this is where I'm actually going to purchase the components. So what you do is you go to building supplies, you have a bunch of options, but we're just going to go to the body tubes for now. Our motor tube, from what we designed in OpenRocket, is going to be 3 inches in diameter. So we go to this 46 to 98 millimeters, which encompasses 2 up to 4 inches. The third 3 inches is going to be on page 2. I've been here a few times. And we're going to look at this lock body tube, specifically because it's cheap. And not all of us are made of money. So here you see that the inner diameter is 3 inches, the outer diameter is 3.1. So that's going to give us the basis for our motor tube. It does come in 34-inch lengths, but ours is going to be 10 inches. And I forget that because this is in a web browser, I can just go back and forth. I'm so used to having my CAD as another application that I have to like go find. So, all right, so let's begin. So first what we're going to do is go to the top datum plane, and we're going to do a sketch. And essentially all we got to do is create 2 concentric circles. In some CAD programs, my preferred one, Creo Parametric, is once you create the circle, it'll give you the option to dimension it. Here you actually have to do the dimensions afterwards. So this is going to be 3.1 as the outer diameter. And you go to do it in another dimension. 3. While I'm in the sketch mode, I'm just going to go over the various options you have up here. You have You have a single line. You can make rectangles, your circles, your arcs, some sort of polygons. So anything up from pentagon up to octagon, all the way up as much as you want. You can have splines at a point. You can add some text to your sketch. And there's construction lines for lines that aren't important. Then some other features that are going to be pretty much commonly used are going to be your fillet. So if you have a sharp corner in your sketch, you want to fillet. Trim is extremely useful, so trim excess parts and lines. Offset essentially offsets the current surface or sketch with some prescribed distance. And then you have mirror, pattern again, and then your dimension tool over here. So now that we have these 2 concentric circles, I'm going to come out of this. We're going to hit check mark, so the sketch is done. Now we're going to extrude it. So you're going to click this extrude button. It automatically goes a blind extrude in the positive direction of the axes. It always starts with 1 inch, at least from what I understand. But other options you could do is symmetric is usually commonly used one if you want to split the plane difference. We're going to stick with blind for right now. And our motor tube is going to be 10 inches long, is what we designed in OpenRocket. So there's our motor tube. Let's go ahead and name it. The parts show up down here at the bottom of your model tree. We're going to name this motor tube. I apologize for my typing, going to be a little bit slower. The interface I have for my computer is a lot different than most people. I don't have a physical mouse or a keyboard, so I have to do everything through the desktop. All right, so there's a motor tube. So we're done with that, so we can hide it. All right, so the next part we're going to do is we're going to do the centering rings. So let's go ahead and do sketch again. Because these are also going to be concentric circles, I don't really need to go into that. All right, and then we want to dimension these. Now the outer diameter of the centering ring is going to be inner diameter for the outer tube, which is going to be 3.9 inches because the outer diameter is 4. And we already saw this is going to be 3.1, which is the outer diameter of the motor tube. There's our sketch. We're going to go ahead and extrude. And because we're going to be cutting these out of 1/8 of an inch plywood, we're going to make these 1/8 of an inch thick. All right, and there's our centering ring. When we go to assemble, we don't have to create another ring, so let's just name this centering ring. Centering ring. All right, so 2 parts down. Our last part is the outer airframe, which is just a little bit more complicated. It's going to be very similar to the motor tube because it's a body, it's a tube, obviously, of cardboard. But we're also going to put slots in it for the fins. So I'm going to go ahead and do the top again just to be a little easier from my handling of these. All right, and we're going to dimension this. This is going to be 4 inches. 3.9. These tubes are really nice. They're strong and they're lightweight. So we're going to say good for the sketch. And then we're going to extrude it. These tubes come in 34-inch lengths, and that's what we're going to use for our rocket. So we're going to do that. So our fins, if you look back at this design, they're going to be removable, so they're going to have a slot through the airframe. So we're going to go ahead and do that. The root chord of this is going to be 7 inches. So we're going to make 7-inch slot, 4 of them on each side. So what we're going to go ahead and do is we're going to do another sketch. And this extrude, instead of adding material, is going to remove material. So we just need a necessary geometry to remove what we want in that little area. So I'm going to create 2 circles. One that's larger than the outer diameter, one that's smaller than the inner diameter. Excuse me. And then we're going to create this, and then we're going to use the offset tool. To use the offset tool, you click on your line. It automatically starts in a default direction and always starts at 0.25. So to change that, we would just hit enter, and it allows you to change the dimension. But because we want 1/2-inch slots, we're just going to keep it the same. And then we're going to have to go in the opposite direction, minus 0.25. So that's that. And now that we have this, the area that we're going to be trimmed, or we want to save, is this little square here. If we leave that, then that is the sole part that will actually remove the material. So we're going to use the trim tool, which is going to be used a lot in this side. So you can trim all this excess sketch, and then you're left with this one little area. So the next thing we can do is we can repeat this process for the other 4, but I'm going to go ahead and use a circular pattern on these. Defaults to 3, and it revolves around the origin. I'm sure you can do some other ways of or other axes revolve around, but the default is the origin. Is why I would start. And by doing that to 4, now we have our 4 fins, and we have our sketches. So with that done, we go up to here, and we hit that. So now we want to do extrude again, but we're going to be removing material instead. So you want to click this remove, add, or actually, this makes sense. If you want to create a new part, you use the new feature. If you want to add, you hit the add feature to the previous part, and then remove is what we want to do. For some reason, when you go from add to remove, it goes in the opposite direction. So I have to do minus 7 inches here. Minus 7. And then there's our slots. So now our airframe is complete. You can hit the check mark. And we can rename this as airframe. You can assign material properties to these. Like if you see here, if I right click, you can do properties, assign material. We will do that when we want to get a better idea of the mass of the rocket. But for now, until we have all the components, excuse me, all of the components designed, we're not really worried about that because we're not worried about the mass at this point. Right now, we'll just, for when we get to the simulation, we'll just say we have a 3-pound rocket. mainly because that's going to be our upper limit. Anything lower is positive. We can have a lower weight rocket, then all we're going to have is a higher altitude at apogee, which is nice. All right, so we have our 3 parts. So now we can go into the assembly tab. This is where you're going to assemble all your parts. Unlike most CAD programs that I'm familiar with that I actually prefer, which use a bunch of datum planes, and you can assemble all your parts according to these datum planes and references. There's a single point origin here. Now it does have a default axis along with it, but you can't see that at this point. And then the other difference is, so because you don't have all these extra datum planes to assemble to, what you essentially do is you assemble your foundational part. So for us, it'll be the motor tube. This acts as like the foundation of your entire assembly that you build off of. So you essentially mate all your components together. So you have a fastened mate, which is a rigid connection. It constrains your part in 3 axes or 3 directions. You have your revolute mate, which would be a pin connection if you wanted something to revolve around an axis. You have a slider mate, which allows things to slide linearly. A planar mate, which just it constrains one direction of travel. Your cylindrical mate, which is a combination of your pin and your slider mate. You have pin slot mate, and you have a ball joint mate, and those are pretty much all the mates you're going to worry about. The other features we'll play with here is you got your patterns. You got linear pattern, circular pattern. We'll use that when we assemble the fins, because all we have to do is assemble a single fin, and then we can just pattern the other 3 around. And then for your mechanisms, if you want to have some kind of relationships, like if you want to have a gear relationship or rack and pinion, screw relation, linear relations, and whatnot, those are your features there. And that's pretty much all that I'm familiar with, reminding you guys I'm new to this. All right, so let's go ahead and start our first thing. I mentioned the motor tube is going to be our foundational part. So what we're going to do here is we want to assemble the center of this bottom of the tube to this origin. So we're going to click the fasten mate because we want it to be fixed. And if I just hover over like the bottom surface, actually, you see how this little axes show up, this little origin at the bottom? What we're going to do is fasten that to this axis. So I'm going to click this, and I'm going to click that. And then we are now assembled to the main component. And then all future parts will be assembled to this motor tube. So the next thing we're going to do is we're going to insert the centering ring. Okay, and we're going to do another fastened connection because these are all going to be rigidly connected. And we're going to do that. So now it's constrained to the top. And what we're going to do is we're going to have 2 of these so that both of them will be fixed. It'll create a nice rigid connection between the body tube and the motor tube. What I'm going to do, because instead of assembling a second part, I'm going to offset this minus 1.875. Enter. And then go away. And then we're going to do a linear pattern. Set the thing, set the direction, and we want to go 2. Well, that's a little too high because I remember I did 1.875, so this also has to be 1.875. Now, you may be asking me why I didn't just assemble the top and do the pattern in the down direction. Well, because I'm new to the software, I couldn't figure it out. You can't type in a negative here. It just won't work for some God-given reason. But for now, this is the way we had to do it. So now we have our 2 centering rings. So the last thing we have to do today is assemble the main airframe component. So we'll go to Insert. We'll set Airframe. And I clicked on another thing. Or the App Store. I don't care about the App Store. All right, so we want to assemble the bottom of these 2 components to be really next to each other. So I'm going to go ahead and zoom in a little bit. Again, you can use your scroll wheel to zoom. I'm going to use this zoom to window. All right, we're done inserting parts. And then we're going to do one last fasten mate. So we want these to be together. Something happened here. I don't know what did, but So it's very touchy on like where you. So like right now it's the bottom center surface, but if I go up any higher, it'll go to the middle. So let's try this one more time. Boom, that's what we wanted. And now because we're gonna have a boat tail coming out of the bottom, what we want to do is offset this in 1 inch. It's probably gonna go the wrong way. Of course, it always goes the wrong way, so let's flip that to -1. And now we have our 1 inch overhang. Go ahead with that. And if I go back to this view and I zoom in closely, well, centering rings were there. Let's see. You can see the centering ring is just above that slot, which is what we want because when the fins are slide in, they'll butt up right against that centering ring. And then our boat tail will cap on the bottom so that we can assemble it. So that's it for this video. I want to keep this quick and short just so you guys get an intro to this CAD software we're using. And just get the initial ball rolling with our CAD model. The next video for CAD, what we'll do is we'll design the fins, the boat tail, and the nose cone to complete all exterior parts of the rocket. I'm going to try and get this next video out within the week, but before that, I have a simulation video that I'm working on. That'll be episode 3 in the series. It's going to overview open rocket simulation capabilities as well as get into our more sophisticated simulation software. This is going to be using MATLAB Simulink for our simulations, so this is actually not a free available software to use, but if you can get access to it, it's extremely powerful, which is why we're going to use it still. So what I'll do now is I'll conclude this video. If you like this video, please put a like on it and leave a comment if you have any comments that you want to do, any suggestions. I want to continue to do design projects, so if you have any ideas for a next design project after this rocketry project, please post them in the comments below. Again, I'll link both Apogee components and OnShape in the description below so you guys can get access to it and start designing whatever you feel like designing. With that, I would like to say good night, or good afternoon, or good morning if you're watching this in the morning. But until next time, take it easy.